Hello everyone. So today we will be starting on chapter 9. And so for the next 2 days we are going to be talking about section 9.1, and then on Monday we will talk about section 9.4, and that is it for the semester, because then Tuesday will be a review day for exam 5, Wednesday will be your exam, Thursday will be another review day just for the final, and then the final opens from Friday to Monday. So, and you get to pick which day you want to do it. And a couple of things I want to talk about, and I'll probably put it in an announcement later on, but one thing I forgot to mention in that first announcement is that it's a 3-hour time limit, and you have to do it in one sitting. Okay, so you can't just spend an hour on it and then decide to take a break. No, you have to take it. If you start it, the timer starts. Like it's started, and you have 3 hours, and that's it. All right, so make sure whatever day you pick, make sure you have enough time where you can do this in 3 hours. All right, so now let's talk about today's lesson, which is part of section 9.1. And if you look in the book, we're going to put things out of order a little bit. So midpoint is the end of section 9.1, but it's a little easier to talk about. So we're going to start with that, and then we'll talk about distance, and then we'll talk about graphing a circle. Right? So the midpoint of a line segment in a plane. So it says, consider 2 points on the coordinate plane. So the coordinate plane is just the XY plane, and the line segment determined by the points. So what does that mean? So if I have 2 points here, the line segment is, pretend it's straight. This right here, the line itself, that is a line segment, right? The difference between, and one thing I want to say about a line segment and a line. So a line, when we graph, like for example, I don't know, let's pretend this is y equals x minus 4. Okay, so when we graph, it's a line. This has infinite distance. It's going to go all the way to negative infinity and then all the way to infinity. So we can't measure the distance of the line. But for the line segment, a line segment has a finite distance, so we can actually measure it. And so with the line segment, we usually make it very clear by putting the points, right? And then we just connect it. And that's why I really emphasize between the arrows and line segments, because a line segment's finite and a line's not finite. All right? So, where was I? So, determined by the points. So, it is sometimes necessary to determine the point that is halfway between the endpoints of the line segment. This point is called the midpoint. So, a midpoint, so essentially what a midpoint is, so you can kind of intuitively guess it because mid is middle. So what does it mean if it's in the mid? If we find the midpoint's in the middle. So that means if I took this line segment and I folded it in half, these line segments would they would equal, right? So, and even if we just measured both the individual lines, then they should be the same distance. All right? So that is the midpoint, but how do we find the midpoint? So luckily for us, there is a midpoint formula, and the midpoint formula states that given 2 points x1, y1, and x2, y2, the midpoint of the line segment between the 2 points is given by midpoint m, so you can just say m, that stands for midpoint, is equal to, and then the x coordinate is x1 plus x2 over 2, and then the y coordinate is x1 plus x2 over 2. So midpoint, your final answer should be a point, right? So yeah, because it says midpoint. Okay, so that point, that keyword point, it should tell you that you should end up with a point. So, but other thing I want to mention is that if you notice, the midpoint of a line segment is found by taking the average of the x-coordinates and the average of the y-coordinates. And again, what is the average? The average is, so if I'm given n amount of terms, okay, so I'll do a concrete example. So if I want to find the average of 1, 2, and 3, how do I do that? What I'm going to do, so to find the average, is we're going to add all the terms, and then we divide the number of terms there are. So in this case, there's 3, so we're going to divide it by 3. And if we add and then divide all this, then we'll get 2. Right? That is how you find the average. And so over here with x1, so we have 2 points, right? So 2 coordinates for each, for x, and 2 coordinates for y. And if we add them, so if we add x1 and x2, and then, so since there's only 2 terms, we divide by 2 to find the average. And that's exactly the same process over here, right? So that is just a little review on average, all right? So that's how I remember it. It's just the midpoint. You just take the average of them, right? If not, you can just memorize the formula, whatever helps you. So now that we know the midpoint formula and we know what the midpoint is, now let's apply it. So now let's do an example. So the directions for our example says find the midpoint M of the line segment with the given endpoints. And we're given 5, 6, and we're given negative 10, 4, right? So I'm going to use this. So first thing is I'm just going to write down the formula. Okay. Right, so this is the general midpoint formula. So how can I solve this? First of all, I need to know what x1, y1 is, and I need to know what x2 and y2 are. So I just get to the point, and we can just pick whatever point. Like we can, so for example, this one I'll just call x1, y1, and this one's x2, y2. Right? If you want, you could make this x1, y1, and this one x2, y2. It really doesn't matter which one you pick, as long as you stay consistent. So if you choose that this is x1, this has to be y1, right? It cannot be y2. It has to be y1. All right? So now that we know what point, so I'm going to use the blue one, so let me erase the green. All right? And I'm just going to plug in my points. So x1 we know is 5, x2 is negative 10. We can divide that by 2. y1 is 6, and y2 is 4. Okay, when I add this, so 5 plus a negative 10, that is negative 5, and then over 2. And then I have 6 plus 4, which is 10 over 2. Right? So no decimals. Okay, keep it as an improper fraction. So this is as simplified as it can be because both 5 and 2 are prime numbers. So the x-coordinate is negative 5 over 2, and then 10 over 2, that can be simplified to 5. Right? So very quickly, so this is our answer, right? This is the midpoint. But one thing, so I want to show you guys that even if you chose this to be x2, y2, and then x1, y1, I promise you will get the same answer. Okay, and since we're just doing one example, I'll go ahead and do it. All right, so I already wrote this down here, so I'm just going to plug it in. All right, so x1 in this case is negative 10, then we add x2, which is 5 over 2, y2 is 6, and then y1 is 4 over 2. Oh, sorry. Okay, this one. So it's honestly it's addition. Okay, so doesn't matter too much because addition is commutative, but I want to stay consistent with what I picked. Oh, okay. Oh my gosh. Apparently, I just can't read my own. Having these two like on top of each other gets a little confusing. My bad. So y1 in this case will be 4, and x2 is 6, right? So let's continue. So then negative 10 plus 5, that is negative 5 over 2. 6 plus 4 is 10. 10 divided by 2 is 5. So as you can see, we get the same answer, right? So you can just pick whatever point you want. So even though, and I did say earlier that it doesn't really matter because it's commutative, but it does in a sense. I still want you guys to make sure you follow it like the x1 plus x2 over 2, and then y2 over plus y2 y1 plus y2 over 2, just so I know you know which one's x1 y1 and then x2 y2. All right. So one thing I want to do, this is not required in our example, but I just want to talk about it. So let's graph these points. So I have 5, 6, so it's right here, and I have negative 10, 4, right? And then let's draw the line. Okay. So I have this line segment here, and then we're claiming that the midpoint is negative 5 over 2, 5. So negative 5 over 2, if I do make it decimal, it is negative 2.5. Okay, so it's like halfway, and then 5. Okay. Oops. Oh my gosh. Okay, so what is this? So the midpoint, so that means that the distance here is the same as the distance here. And then actually, so you'll have to watch the video about the distance, but what I want you to do, so after we learn about what the distance formula is, so here's another extra credit, okay? I want you to find the distance between, this is negative 10, 4, this is negative 5 over 2, 5. I want you to find the distance between between these 2 points, and I also want you to find the distance between negative 5, 2, and 5 with 5, 6, right? And then I want you to show me that these distances are the same. However, we do need to talk about distance first, okay? But just keep this one in mind that this will be an extra credit opportunity. Today's going to be the 30th, so we can make this due Friday 5-1, again at 11:59 p.m. Okay, and then this will be worth 2 points. Okay, make sure you do write down these points. You need to write down this, this, and this, and you need to, just tell me about the distance and everything. All right, so this is it for topic 1, and then topic 2, we will talk about distance, and then, it'll be a tool that you can use to solve this extra credit. So, see you in a little bit.